Howdy folks, Mr. Reed here, and welcome to One More Question. So what I'm going to be taking a look at right now is actually applying what I've been looking at in the last couple of videos in terms of looking at some real numbers with some real rational exponents and looking to simplify those expressions. So if you'd like to actually apply those things we've been learning, then you're in the right place. So let's get to it. Okay, I have three examples up above. Some of them are pretty straightforward. But let's just go in order and we'll see these things happen as we get there. So the first one is 27 to the 1/3 power. Now the 1/3 power acting on 27, we have just discussed in our previous videos that this means the same thing as a particular root. Now, if you're really comfortable with this already, you just go for it and you probably know what the answer is to 27 to the 1/3. I'm going to assume that we don't really have a comfort level yet, and so I can write that 1/3 power by recognizing that that's a 1 for the number that's in the numerator of the exponent, and so the 3 that's in the denominator is what's going to determine the index of the radical that I write. So in this particular case, I'm going to get the third root of 27 is the equivalent to 27 to the 1/3 power. Great. I actually do know that 27 is a nice perfect cube, so the opposite of cubing something is cube rooting it, and so I would have 3 times 3 times 3 gives me 27, so the cube root of 27 ends up being a 3. Awesome, so that's that first one. The next one is 25, sorry, it was a little bit messy there, but 25 to the 1.5 power. Now, the problem is that last time I discussed how to do this with rational exponents, which means that it includes decimals, but I didn't actually show you how to do it with a decimal. So what I would probably do is write down what does that mean as a fraction. So 1.5 is 3 divided into 2 pieces, so 3/2 is the same thing as 1.5. However it is that you like to convert that from decimal to fraction form is up to you, but in this form it's something that I can understand a little bit better. Now, we also talked about in the last video that what this means is that I have a 3 that is going to become kind of my repeated multiplication power, and I have a 2 that's going to become the index on my root. So that's going to mean I'm using a square root. Usually we don't write in the index on a square root, but that's fine. But we also talked about how the order doesn't matter. So I'm sitting here without a calculator. So I have two options. I could multiply 25 times itself 3 times, which would be 25 times 25 is 625, but then I'd be slowing down significantly for 625 times 25, and we would be sitting here for a little bit as I tried to make sure I wouldn't make a mistake on that. However, that is not the best order for me to do things, and afterwards I'd square root it. I can decide to use the square root first, which brings it down to a 5, and then I can multiply 5 times itself 3 times, which is going to be 5 times 5 is 25, times another 5 is actually a very, very nice value of 125. Now, if you want to see what I'm really doing is I am writing it like this. The square root is going to be done first, and then I'm applying the power of 3. Technically, I'm going to write it above, is the same thing as cubing first and then applying the square root afterwards. Now, I didn't need a bracket inside there, but that's okay. So those things are equivalent. Mentally, this is much, much, much easier. So as we said, square root of 25 is 5. Cubed would be 125 as an answer. Great, so we know what 25 to the 1.5 power means. One thing there is 25 to the first power is 25. 25 to the second power is 625. So just make kind of note that 125 is definitely not halfway in between 25 and 625. So a 1.5 power doesn't mean go halfway in between your powers. It means something a bit different, and as we see, we can represent it using this other notation and figure out our answer from there. So my last one is 8 to the 5/3 power, and again, This time I don't need to convert this into a fraction. Instead, it already is that way. And I could choose to do 8 to the 5th power and then do the 1/3 power, which is a cube root afterwards. But I'm going to choose not to go that route because, again, 8 to the 5th power, I'm going to get really out of sorts quite quickly there. So I'm going to instead say, what if I were to take the 1/3 power first, which is the same thing as the cube root. So I'd take the cube root of 8, and then after I'm done that, I will then apply the 5th power to it because the order doesn't matter. So the cube root of 8 is going to give us a 2. And then we still have to apply that 5th power on 2, but that's not too bad. 2 times 2 times 2 is 8, times 2 is 16, times the last 2 is 32. So there we go. I've evaluated those three numbers by using this idea of what these rational exponents really mean in terms of if they work out kind of this nice rational way, which is of course all I've said. What we're using is rational exponents. We can kind of use the idea of repeated multiplication for the numerator and some sort of index on a root for the denominator. Now, of course, if you get into some interesting questions, I probably should save this for another video, but if you have an inquiring mind, something that you probably could ask yourself is, well, we've talked about some irrational numbers. Well, what would this mean? 2 to the power of pi. Because pi is a number, but it's not a number you can write as a fraction. So what that means is there is no numerator over denominator. So it's not a particular power over a particular root or index on a radical. So what in the world is this supposed to mean? I'll just leave that with you for now. So hopefully you found that one interesting or helpful. And if you did, like, subscribe. And as always, take care, folks.